So today I'm going to show you how to determine a complex number in polar form. So first thing first, so according to the summary that I've given you, so you can see that there are two forms of complex number. So the first form is Cartesian form, whereby z is equal to a plus bi. So you can see here a is the real part of the complex number, and then b is the imaginary part of the complex number, and I is set of -1. Then the second form of complex number is polar form. So polar form is expressed as z equals to r multiply cos theta plus I sin theta, whereby r is called the modulus of z, modulus of the complex number, and we do have this formula, set or square root of a squared plus b squared. And one thing that we have to know that r must be positive. Why? Because modulus is basically the length of the complex number. So that's why it's always positive. And then for the argument, so theta. So first thing, if you can see here, the unit is the angle is given in pi, so that means the unit is always measured in radian for theta. For the argument in this topic, so we will always measure theta in radian. So theta is a value between -pi and pi, right? So there is equal sign here but not here. And one more thing that you have to know is theta is always measured from the positive x-axis. Meaning that, for example, so this is our Argan diagram. The x-axis is represented by the real value and y-axis is represented by the imaginary. So for example, if your complex number is located in the first quadrant, for example, this is the z, so theta is always measured from this positive x-axis. This one is negative x-axis, so we always measure here from positive x-axis. So if our complex number is located in the first quadrant, so that means theta here is acute. So that is our argument. Second example, let's say is if our complex number located in the second quadrant, so since argument is always measured from positive x-axis, so we know that this would be the argument. So it's going to be an obtuse angle, right? So then next example, if you have the complex number to be located in the third quadrant, so and again the angle is always measured from positive x-axis, so this is our theta. So it's going to be obtuse and it's going to be negative. And then when you have the complex number to be located in the fourth quadrant, so again it's always measured from positive x-axis, so you get your theta to be acute and also negative. So now I'm going to show you examples, right, on how to transform complex number from Cartesian form to polar form. So example 1. So let's say if our complex number is z equals to 1 plus 2i. So first thing first, in order to transform from this Cartesian form, to polar form, it's z equals to r cos theta plus I sin theta. So basically we need to find the r and the theta. So this is polar form. Okay, so we need to find this r and we need to find this theta. Okay, so again, r is modulus of complex number, and we do have formula, and the formula is fixed. It's square root of a squared plus b squared. Okay, so a is the real part of the complex number and b is the imaginary part of the complex number. So you just get the numbers, the values, and you substitute into the formula. So it's 1 squared plus 2 squared. Okay, so if you can see here, 1 squared is 1, 2 squared is 4, so 1 plus 4 is 5. So the answer will be set 5. Okay, so that is our modulus. Okay, now how to find the argument? Okay, so I'm going to give you tips. Okay, in order to find argument, okay, you just follow these 3 steps. Okay, in order to find argument, okay, which is theta. Okay, so basically you just have to follow these 3 steps. First, you determine the quadrant of where the complex number is located. And second, you identify the angle. Okay, the angle, it's either acute or obtuse. Okay, and then third, you identify the sign. Okay, whether it's positive or negative. Okay, if it's located in the first and second quadrant, so your angles are going to be positive. If the complex number is located in the third or fourth quadrants, so the angle is going to be negative. So that's the tip. Okay, so you have to follow these three steps. Okay, so in order to find argument of this complex number, so okay, let us draw the Argan diagram. So this is real axis, this is imaginary axis. Okay, so our complex number just now is 1 plus 2i. Okay, so 1 plus 2i means, okay, it moves 1 unit to the right, okay, since the real value is 1, and then 2i means it moves 2 units above. Okay, so that means we know that our complex number is here in the first quadrant. Okay, so this is our z. Okay, and because, okay, just now I mentioned argument is always measured from positive x-axis. Okay, so then you just go up here until you reach the complex number, then we can identify that this is our theta. So based on the 3 steps just now, okay, so we can determine that our complex number is located in the first quadrant. Okay, so because you can see that the argument here is less than 90 degrees, okay, or it is less than pi over 2 in radian, so it is acute angle. Okay, and then because it's located above x-axis, so our angle is going to be positive. Alright, so then how can we find our theta? So theta is equal to inverse tangent of b over a. Okay, so we have b just now, the imaginary part, which is 2 divided by a, the value of a is 1. Okay, so you just press calculator and make sure you set your calculator to radian mode first. So inverse tangent of 2 will give you 1.11 radian. Okay, so let me ask you, why do we have tangent? Why not sine or even cos? So if I take the triangle, I take out the triangle, so this is our theta. Okay, so because our complex number is 1 plus 2i, right? So that means, okay, this unit, it represents the real value, so this is 1. And then this unit represents the imaginary value, or imaginary part value, so it's 2 here. So you have 1 and 2. Okay, and if you can see here, this is the opposite of the angle, right? Okay, opposite. And this is adjacent. So you had learned before, right? So if you have opposite over adjacent, Then this is particularly for tangent. Right, you learn the sohkah toa. Correct or not? Sine equals to opposite over hypotenuse. Cos equals to adjacent over hypotenuse. And tangent equals to opposite over adjacent. So that's why in this formula, we use particular tangent function. Okay, so what would be the answer? Okay, so originally our complex number just now is 1 plus 2i. So this is Cartesian form. Okay, so in order to write in polar form, so we have got our r, it's set 5. Okay, multiply by cos theta. So you just write down cos theta. So theta 1.11. Okay, plus I sine theta. So since the theta is 1.11, so you just write it down. Okay, so that means this is our complex number in polar form. Alright, okay, so now let's move on to second example. Okay, second example. Okay, I'm going to give you complex number, but this time it will be located in different quadrant so that you can see different cases. Okay, so z equals to -1 plus 2i. Okay, so in order to find modulus, it's very simple. You just follow the formula. Square root of a squared plus b squared. Okay, so since the value of a is the real part value, so you just bring down the negative. Make sure you take everything together with the sign. So -1 squared plus the b value is +2. But still, okay, the value or the length would be the same. Okay, set 5. Okay, then how to find the argument? So remember these 3 steps. Okay, so first thing first, okay, determine the quadrant. Okay, so that's why it's important for you to draw the Argan diagram. And then second, the angle. Okay, so we are going to determine whether the angle is acute or obtuse. Okay, then third one is the sine. Okay, so because these 3 steps here, okay, they will determine the formula, different formula to find the argument. Okay, so now let's draw Argan diagram. Okay, always x-axis represented by real axis, y-axis represented by the imaginary. Okay, so now where is our complex number located? Okay, you see the real part is -1, so that means it moves 1 unit to the left. Okay, then 2i, positive 2i, so means it moves 2 units above. So we know that this is our complex number. Okay, so this is z, -1 plus 2i. Okay, so and as I said just now, argument is always measured from positive x-axis. So that means from this positive x-axis going up until we reach this complex number. So this is our theta. Okay, so how to find theta? Alright, because we know that the length here, okay, so this is 1 and this is 2. We measure the length. Okay, we measure the length. Okay, so this is 1 and this is 2. So in order to find theta, so okay, we need to find this angle first, and we name this as alpha. Okay, so based on our diagram, so we know that our complex number located in second quadrant. Okay, and then the angle is obtuse this time. Okay, and then the sign is still positive. Why positive? Because it's located above x-axis. So positive. Okay, which means the formula of finding this argument. Okay, so the formula of finding this argument will be, okay, positive. Okay, we put bracket pi minus alpha. Okay, why pi? Because pi in degree is 180 degrees, right? So because we know that the total here 180. So, okay, 180 minus alpha will give us this theta. Okay, so, okay, then let's find the argument. Okay, so for the negative, if you don't put the sign, it's understood. Yeah. Okay, so you have pi minus alpha. So in order to find alpha, again you have opposite and you have adjacent here. So it's simply inverse tangent of opposite over adjacent, which means 2 over 1. Okay, and yeah, you see, even though originally the complex number is -1 plus 2i, but here we write down the unit as 1, not -1, because we measure the length. We are talking about the length. Okay, not the value. Okay, so the length here is 1 unit. Okay, so we have, okay, inverse tangent of 2 over 1. So you press calculator and you will get again 1.11 radian. So pi minus 1.11 radian will give you 2.03 radian. Yeah. Okay, so it is optional for you to write down the unit. Okay, so how to express this complex number? -1 plus 2i. Okay, from Cartesian form to polar form. So we have got our r. So r is sec 5 times cos theta. So cos 2.03 plus I sine 2.03. Okay, so this is the polar form of this complex number. Hence, this is the answer.